B16 is a standard for miniature circuit breakers, often referred to as MCB, used in electrical installations for short-circuit protection. The designation B16 indicates specific characteristics of the circuit breaker. Firstly, it specifies the rated current. In this case, the rated current is 16 amps. This means the circuit breaker is designed to handle a maximum continuous current of 16 amps without tripping. If the current exceeds this value for a sustained period, the circuit breaker will trip to protect the circuit. Secondly, it defines the tripping curve, indicated by the letter B. The tripping curve describes the time current characteristic of the circuit breaker. It determines how quickly the breaker will trip under overcurrent conditions. A B curve is designed for relatively fast tripping in response to short circuits, while still allowing brief overloads such as those experienced when starting motors. This balance is important to prevent nuisance tripping while ensuring adequate protection against faults. The B curve indicates that the circuit breaker will trip within a specific time range depending on the level of overcurrent. For example, it might trip within 0.4 to 13 seconds at 3 to 5 times the rated current. Thirdly, the B16 circuit breaker provides short-circuit protection. It is capable of interrupting short-circuit currents up to its rated short-circuit current rating, often abbreviated as SCCR. The SCCR is a critical parameter that indicates the maximum fault current the circuit breaker can safely interrupt without failing. This ensures protection against hazardous electrical faults that can cause damage to equipment, electrical fires, and potential injury. It's important to ensure that the SCCR of the circuit breaker is adequate for the potential fault currents at the installation location. B16 miniature circuit breakers are commonly used in both residential and commercial electrical installations. They are designed to protect circuits from a variety of electrical faults, including short circuits caused by faulty wiring or equipment, overloads caused by excessive current draw on the circuit, and ground faults caused by insulation breakdown. Short circuits occur when there is a low resistance path between 2 points in a circuit that have different voltages. This can result in a very high current flow, which can quickly damage equipment and cause a fire. Overloads occur when the current in a circuit exceeds the rated capacity of the wiring or equipment. This can cause the wiring to overheat and potentially start a fire. Ground faults occur when there is a fault between a live conductor and ground. This can create a shock hazard and can also cause a fire. B16 MCB are typically installed in a distribution board or panel, often alongside other circuit breakers and protective devices. The distribution board serves as a central point for distributing electrical power to various circuits within a building. The circuit breakers within the distribution board protect each circuit from overcurrent and short-circuit conditions. They are an essential component of electrical safety, helping to prevent electrical fires, damage to equipment, and potential injury. When selecting a circuit breaker, it is important to consider the specific requirements of the circuit it will be protecting. This includes the rated current of the circuit, the type of load that will be connected to the circuit, and the potential fault currents at the installation location. The rated current of the circuit breaker should be equal to or greater than the maximum current that the circuit is expected to carry. The tripping curve of the circuit breaker should be appropriate for the type of load that will be connected to the circuit. For example, a circuit that supplies a motor may require a circuit breaker with a different tripping curve than a circuit that supplies lighting. The SCCR of the circuit breaker should be greater than the potential fault currents at the installation location. Regular inspection and testing of circuit breakers are essential to ensure they are functioning properly. Circuit breakers should be inspected periodically for signs of damage or wear. They should also be tested to ensure they trip properly under overcurrent conditions. If a circuit breaker fails to trip when it should be replaced immediately. Miniature circuit breakers are designed to be manually reset after they trip. To reset a circuit breaker, simply switch it to the off position and then back to the on position. If a circuit breaker trips frequently, it may indicate a problem with the circuit it is protecting. In this case, it is important to investigate the cause of the tripping and correct the problem. This may involve checking the wiring for faults, reducing the load on the circuit, or replacing faulty equipment. It is also important to ensure that the circuit breaker is properly sized for the circuit it is protecting. If the circuit breaker is too small, it will trip frequently, even under normal operating conditions. If the circuit breaker is too large, it may not provide adequate protection against overcurrent and short-circuit conditions. It is essential to consult with a qualified electrician to determine the appropriate size and type of circuit breaker for a particular application. In addition to B16 circuit breakers, there are other types of circuit breakers available, each with its own unique characteristics and applications. For example, C-curve circuit breakers are designed for higher inrush currents, such as those found in inductive loads like transformers and some types of lighting. D-curve circuit breakers are designed for even higher inrush currents, such as those found in welding equipment and large motors. The selection of the appropriate circuit breaker depends on the specific requirements of the application. Proper installation and maintenance of circuit breakers are crucial for ensuring electrical safety. Circuit breakers should be installed by qualified electricians in accordance with all applicable electrical codes and standards. They should be inspected and tested regularly to ensure they are functioning properly. Any damaged or malfunctioning circuit breakers should be replaced immediately. By understanding the characteristics and applications of B16 miniature circuit breakers, individuals can ensure the safety and reliability of electrical systems in residential and commercial buildings. It is always recommended to consult with a qualified electrician for any electrical work to ensure that it is performed safely and in accordance with all applicable codes and standards.